Hey, Intro to Calc, and welcome to Task 6.8. This is in two parts, so I'm going to talk about each part separately. As always, make this video super valuable for you. Pause it, fast forward, rewind it, or change that playback speed. So to give you just a quick little info piece, I'm only expecting to see your work, like actual detailed steps, on the first part of this task. So this page, I am expecting you to show your work. But the second page, I just want your answers. Solutions will be posted online for you to check. I'm going to give you some hints along the way. So I really just want to see your answers. Again, it's a learning experience, so don't shortcut it by just using PhotoMath or another application. Go through the process of learning how to do these. I just want to see that you got the correct answers. With that in mind, let's start this first half where you do have to show your work. You are now being introduced to some brand new formulas. These are called the sum and difference formulas, meaning any angles in our unit circle, we can add them together, we can subtract them, and still find the sine and cosine. Here are the double angle formulas. Any angle on our unit circle, we can double it and still find the sine and cosine. So why are these useful? Our unit circle has a very limited number of values, very, very, very limited. This is widening that kind of list of angles we can now use. So for example, 75 is not on our unit circle, but if we think of it as a combination of, if we think of it as a combination of 45 plus 30, now we can actually find the sine of 75. 15 is also not on our unit circle, but if we think of it as a combination of 45 minus 30, now we can actually find the sine of 15. So let's practice these. I'm going to leave the top to you guys to practice. Hint, hint, hint. They all should reach the same exact answer, and that answer is 1/2. They all should reach the same answer, and the answer is 1/2. But I want you to actually show your work. How to use a sum formula, how to use a double angle formula, and how to use a difference formula. But I'm going to show you one or two of the ones below. So let's go ahead and start with the sine of 75. So I want to remind you here that there are infinitely many methods. There's not just one method to this, but all of your methods should reach the same answer. So I'm going to go with that kind of first one I pitched to you guys. That this could also be the sine of 45 plus 30. And I'm going to ask that you guys not use this when you actually submit. Sorry, those degree markers looked weird. I'm going to ask that you not use this when you submit. Try something else. Think a little bit more creatively, not just 45 plus 30. But that being said, let's try this out. Let's look at the formula up here. Sine of u plus v. So this would now be our 45. This would now be our 30. What this tells us is that we're going to do the sine of the first angle, 45, times the cosine of the second angle, 30, plus the cosine of the first angle, 45, the sine of the second angle, 30. So we're going to expand into this larger formula. Sine of the first angle times cosine of the second plus cosine of the first angle times sine of the second. And the great thing about this is that we know all these values. Have your unit circle handy, or just trust that I know mine. Sine of 45 is radical 2 over 2. Cosine of 30 is radical 3 over 2. Cosine of 45 is radical 2 over 2. The sine of 30 is 1/2. So now using our unit circle, we can find the sine of 75. The sine of 75 is radical 6 over 4 plus radical 2 over 4, which we're just going to write as radical 6 plus radical 2 all over 4. Oops. So that is how you would use a sum formula. Same applies for the difference formula. I just want to look at cosine for a second. You'll see here cosine's a little bit different. When we are adding the two angles, that means we're subtracting these two expressions. So if I wanted to do that cosine of 30 plus 30, I would be subtracting the two expressions. Now, conversely, when I am subtracting, say if I wanted to do 45, let's put this in a color you can see, 45 minus 30, I would be adding the two expressions. So cosine 45, cosine 30 plus sine 45, sine 30. So that's why that's written upside down, because it swaps. If I am adding here, I'm subtracting here. And then a quick note for your double angle formulas. There is only one double angle formula for sine, but there are 3 for cosine, and they are all interchangeable. You can use whichever one you want. I always end up using this top one for the most part, just because it's easy for me to remember, and I like the fact that I end up with the same denominator. Like, I don't have to think of a denominator. It's always like something over, 4 minus something over 4. I don't have to think about finding a common denominator, but they all work exactly the same. So go ahead and give these ones a try. Show your work. That's the main idea on this page. I want to see your work. I want to see your process. If you'd like to pause the video now and give these a shot and try them, go for it. And here we are on part 2. Part 2 is a little bit different. Part 2 is kind of saying, hey, you have everything you need. You know how to factor. You know reciprocal and Pythagorean identities. I listed them here on the side just in case you've forgotten them. You now know double angle formulas, and you now know sum and difference formulas. Can we put this all together to solve some trig equations? So we're going to find all the solutions for these trig equations on just one rotation of the circle. Just one rotation. So if you've done those Khan Academy problems had you saying, well, the solution could be here and it could be here, but let's rotate 360 and let's rotate another 360 or 2 pi and another 360. We don't have to do that this time. If our circle says the solutions are here and here, those are the only solutions we're going to go with. So don't worry about going outside of that first rotation. But let me give you some hints to get started on these. And then, like I said, solutions are posted separately. I'm going to start by circling the ones that look really, really familiar to me. In all of these, I'm seeing a pattern. Let's see if there are any more. Nope, those are the ones I'm seeing a pattern in. If I replace the trig function with just x, 2x squared minus x minus 1 equals 0, that is factorable. If I replace this one with just x also, 2x squared minus x minus 1 equals 0, hey, that's also factorable. And what about this one? 2x squared minus 3x plus 1, that is factorable. All of these are factorable, so I want you to factor them. Factor them, solve them just like you would have back in Math 2 the first time you did factoring, back in Math 3 when we revisited factoring, back at the beginning of this year when we, or this semester when we did factoring. Do them the same exact way. But when you get to the end, if you have a solution that was x equals 1/2 or x equals 1, and I don't think those are correct, I'm just giving you an example. Instead of x, it's now cosine x and cosine x. So that's the only difference. So for those guys, look to factor. In fact, if there's any opportunity to factor, that's my first go-to. So let's make this an ordered list. 1, try factoring. If you can factor, awesome. Here's another hint for you guys. On number 2, these are not the same trig function. So while I want to factor, I can't. But can I make this guy into a sine? Well, I sure can. This Pythagorean identity right here can be rewritten as cosine squared theta equals 1 minus sine squared theta. So I can just substitute 1 minus sine squared theta into this. And by the way, theta, just like x, they're just variables. So I can go ahead and write 1 minus sine squared x. And now I'm all in terms of sine. Let's try to factor, let's try to solve this as if this really was just x, not sine x. Same goes right here. These are not the same function. Sure, they're both sine, but this one is 2x and this one is x. But I have some new formulas. Do I have a formula that can somehow change this sine 2x into a sine x? I do. I'm going to flip back to the last page right here. My sine 2u, or 2x, is sine 2x cosine, 2 sine x cosine x. So I can substitute that in. But do me a favor, guys, and do not divide by sine x. Don't do it. Don't do it. I'm giving you a big warning right now. Don't do this. Don't do this. We can't divide by sine x because sine x can equal 0. And so technically we're dividing by 0. Don't do it. Find another way around that one. Find another way around it. So this is the right first step, but find another way to go. My last hint for you guys is going to be on this problem and this problem. Ooh, this one too. These all are using our new sum and difference formulas. Sum and difference. So if we look at this, this actually has a sum and difference right there. Expand this. Expand this using the sum and difference formula. You'll see some really nice things happening. This one, same thing. These are sum and difference formulas. Expand this. Use those sum and difference formulas. I promise you it's going to look really long and messy, but it's going to work out really nicely. And this one, well, this looks like either a sum or difference of sine and cosine. This looks like that expanded form. Sine of one times cosine of another, cosine one times sine of another. I feel like I just said that a minute ago in this video. That looks like one of these. So let's do the opposite. Let's condense this. Condense this using one of those formulas, and you'll find that one work out quite nicely. So hopefully I've given you some hints to get started on these. Again, you don't need to show your work on this page. I just want to see your solutions. So come to office hours for some